Okay, hello students. In this video, I would like to do the exercise. But before I continue with the exercise from 2.2, let me get back to the ending examples, which maybe I did not get enough time to explain. And this was the example 16.1, which says, or find the probability of randomly drawing 5 cards from a deck of cards, right? Now, this is always the first step, which this is the step one, which helps us to figure out when you talk about probability, basically asking probability of what? Probability that when you pick 5 cards, your it has two exact, so it should have exactly two aces, two aces. Now we know in a whole deck of cards, if this is the deck of cards, if this is the deck of cards, we know that this deck of cards has 52 cards, and out of these 52 cards, we know there are 4 aces, right? Now, first question is, remember, probability is always a ratio where the bottom is the denominator is all denominator is all possible outcomes. So the question is, in how many ways can you uh, pull out 5 cards from 52 cards? So 5 cards are pulled up, and there is no order here. Just order does not matter. Randomly 5 cards. That means from we have to use the combination. And what is that combination is? You have to put a C, and you from 52 cards you are picking 5 cards. So that's what the denominator. So this is the first step. That's why I say this is step number one, where you first figure out only the bottom number. Now the top number, the numerator, this is the numerator will be is have to be 2 aces. Now, how many aces are there in a deck of cards? So this itself is there are 2 steps here itself, 2 aces. That means if you pick 2 aces, that means the remaining other 2 cards, the other 2 cards will be 3 non-aces. So they will be non-aces. Now, what that means is we have to use fundamental principle of counting here again, because to write the numerator, we have 2 parts. The first part is what is the, so there are 2 parts. See, we are multiplying two, two numbers here. So the first one is you want to have 2 aces from 4 aces. So the from 4 aces, so 4C2. And once that is done, then next is that you have to pick 3 non-aces. So that means three non-aces. That means you're going to do C, but with 3 cards have to be picked up, but they should be non-aces. Now, what that means is 52 cards, you have to take away the aces card, and that will be 48. And that's why we put 48 here. Now, on your calculator, you can figure out this piece. You can directly put 4C2 times 4C2 minus times 48. C3, you end up getting 103776. And if you do the bottom piece, you get 2598960. And then take the ratio, which is 399, and you're done. Okay. So this is how it works. Now, what's the difference between this 16.1 and the next one is, in the next one, they're asking you 3 aces, exactly 3 aces. See, this is 3 aces. That means exactly the same thing, probability of uh, exactly 3 aces will be, the bottom piece stays the same. That means 52 cards, and you're picking 5 cards. That stays the same. But this will change because you want to have exactly 3 aces. Since there are 4 aces, and you're picking uh, 3 aces, so it will be 4C3. And then again, instead of this stays the same, that is 48. But non-aces will be because 3 aces and the remaining on the other two, because all cards are 5 of them, so this will be 2. And again, you can do a little work there with this. I think that gives you uh, So this question was little tricky. If they had to ask only exactly three aces, then this would be a correct answer. But what they give is they said uh, three aces and two kings. So they did not say exactly three aces. So the other cards are two kings. So altogether there are four kings. So we'll have to change this. So we'll have to take this 48 off, and instead of that, we'll have to put 4c2. So this is the beautiful part here is that it is saying three aces and two kings, and that's why we have to say from four aces you have to take off two aces, and that can be done by 4c2. And this piece we can figure out. This answer will be the top number. This from the calculator will be 8. I mean 24. The bottom number will be the same, like how we have this thing, this will be the same over here, 2598960, and you will end up getting answer as 0.12345592, and that's it. So I hope this makes sense. And let's see another one. This is question number, I think this is question number 17. Okay, 17. Okay. So this question is about breakdown of students' body, that is race, ethnicity at Pima Community College in the 2020. They gave so there are 37.3, which you if you want to write in the decimal, it is so white population is 37.33. So in the we can write in the relative to 1, that's like 0.33. Now this is white. This is the white. Okay, this the black is, I'll put B is 0.093, and then Hispanic is, I'll put H, which is 0.4716, and Asian is 0.0312, and then we have Native Americans is 0.097, and there is also others which are undeclared, which is 0.049, 0.549. This is 549. And this is others. So we can say this is other, this is Asian, I'll put A, and this is Native Americans, we can put American Indian, right? Indian American. Okay, the question is, we can write this in a nice orderly manner also. So we can say, okay, outcomes. So first could be outcomes and their probability. So what is the probability basically means? They gave us that this itself is the probability. That means the first one is the white. Okay. Then we have the black. Then the Hispanic. That's the Hispanic. Then we have Asian. Then we have American Indian, and then others. So what is the meaning of outcome? Is suppose if this is the Pima Community College and you want to select a student, what are the probability outcome that is the selected student here is maybe, let's see, first one Hispanic. So Hispanic means this one. So let's call this as H. This can be black. This is the white. This is Asian. This is Asian American, Indian American, and the others. So the first question, what is the probability that when you select a student, the chances that the student selected is a Hispanic? So what is the probability of a student selected is Hispanic? Is already given to you, and there it is. I already wrote here. Hispanic is here. So this is that 0.4. They gave us the percentage, but I already wrote the probability of that. So this will be white is, so these are the same number I'm writing as 0.93. I think, sorry, this is 0.93. the white population is more, so that is 37%. So this is so this number has to be written here 0.373 and 3. So Asian is 0.0312, Indian American is 0.097, and the others is 0.0549. Now the question is asked next is, if a student selected, what's the chances that he's not white? It means he is a minority. Now the minorities are all these four cases: Black, Hispanic, Asian, American Indian, and others. So you just have to add all this, and when you all around this, it means you're going to probability is probability that the student is minority. I'll just write this. So all you do is probability that he can be black, or probability that he can be Hispanic, plus probability he can be Asian, plus probability he's American Indian, or plus probability that he's the other. So all are you doing is you're adding all this. You can write here plus all those five numbers, okay, and you end up getting 0.6267. Okay, that's it. And there's another way to do also could have been later on. We'll see in the next class. So instead of doing all that, since they are asking you non-white, uh, all this number add up to one actually. So if they ask you probability of non-white is actually from one you are taking away the white, probability is a white. So you could also do 1 minus the white is given here is 0.3733, and you end up getting the same answer. So anyway, hopefully I will see that in the next class. So this question is asking a student. Uh, so the student body in a high school. Now this one is given you 10 categories because there are 5 categories, and each category they try to break this into male and female. So what we can do is I'll have to make a column first to show that first is all the gender. Let me do this first. Mm, so I'll make this 5 column rows to show the type of ethnicity or the race. This is like a race. Which one is maybe first one is the white. Let me write this again so that you really get this one. This is black. Then we put Hispanic. Okay, this is black, Hispanic. Then we have Asian. Then we have, you also have, and others. I think we have only, yeah, this is the fifth one, and others. So race, and now in this one I have to break this into uh, 2 more columns just to show that it is the gender. Now what is the gender is male and female, right? So these are male, this is male, and this is female. Okay. So let me take this off and write this one is male and female. So this is male and this is female. Okay. Now this is the white, this is the black, this is the Hispanic, this is the Asian, these are others, right? Now let's start from the first one. This one says 25% white male. So white male means it will be, now it is 25%. Basically, we can write its percentage. It means 0.25 divided by 100, which is 0.25. So that means because it's talking about white male, I have to write 0.2 and 5. See, the next one is 26% white female, so that will be 0.26. Next is 12% is male, black, so that means 0.12, and 15% is black female, so that's again 0.15. Okay, 6% is Hispanic male, 0.06, and 5% is Hispanic female, 3% Asian, that means 0.03 male, and sorry, I think both are 3%, so male and female are equal. And others is 1% male, 0.01, and 4, 4 per, I think, did I make, yeah, and 4% female, yeah, 0.04. So this is like how you organize. And the question is asked, once we have this, if a student is selected, what's the chances or probability that the student is black? Now, black basically means will be this piece. So you have to add male and female. So this answer will be, you'll have to add probability that it is black. Suppose I want to write he's a black. So probability that he is a black male plus probability that he is a black woman. So that means we have to add these two pieces, 0.25 plus 0.26, which will be 0. Sorry, I made a mistake. Not that one. This one. This should be. This should be black. This 0.12. So this is 0.12, and this is 0.15. So this is 0.12 plus 0.15 will add up to 0.27. Okay, so that takes care of the first one. The next question is the student is minority female. Now, what is this minority female? That means these are females, but minority basically means apart from this is white, right? This is white female. We don't want white, we want the rest of them. So, probability, the second B, if this B, probability that it is going to be a minority female is so he could be. I just wanted to show actual outcomes. Could be he could be so. So what are the chances? Will be it is like probability that he is going to be black female, or plus probability that black or Hispanic female, plus uh, probability that he is an Asian female, plus probability that any other race, which is O female. Now all this is written just to organize, to show there are these are the pieces. So all you do is you just add up those things. Okay. So this will be, you add this 0.15 plus 0.05, all this. Okay. 0.04, and you add up, you get 0.27. Okay, so I hope. So the last question C is what is the probability that the student is a female? So probability that a student is a female, so that means it could be probability that it is a white female plus probability that it could be uh, black female plus probability that the Hispanic female plus probability is the Asian female plus probability of other females. All the five will be added. So 1, 2, 3, 4, and 5. So when you add this, you put in the calculator, you'll get 0.53 and you're done. So I hope that makes sense, to get an idea of how in real application we can understand what percentage is like. This helps you to understand also the reality in high schools, maybe in one of the high school, I don't know where, how the students population is divided. Okay, let's do the exercise now. This is the important one because if you understand this, then your homework will be easy, and it's like preparing also for the exam one. So if you see, the first question is asking which of the following can be probability value. Now, when you talk about probability value, the small p, it is always has to be 0 and plus 1. It cannot be negative, cannot be negative. Okay, so if it cannot be negative, that means your answer could not, this is wrong. These are the two pieces which cannot be the answer. Also, your number, your p cannot be more than 1. And you can see this number which you see is 7.5. This is like 1. If you use the calculator, you will see it is 1.4, or it is also 1 2/5 like this. See? So this is bigger than, this is greater. This is greater than 1. So that greater than 1. So this cannot be the answer. And then also you will see this number √2 on the calculator, it will be 1.41. So this also cannot be. So the only, what about 1 over this means it is 1 over 3.14, and the down number denominator is big and this is small. So whenever the denominator is bigger than the numerator, this will be less than 1. So this basically means less than 1. So this can be the answer. And 1 also can be, because that's equal sign here. 0 also can be, so there's a 0. And what about 5 over 7? So if you see 5 over 7, this is less than 1, which is because 7 is big, this is small, so that also is correct. Okay, I hope that takes care of this. So this question number 2 is a box contains 4 black and there are 4 black and 4 white. So here there are 10 black, 1, 2, 3, 4, 5, 5, and 2, and there are 4 white. Instead of white, I'll put it like, white, I'll make it like a green. So there are 10 white and there are 10 black. So now you want to draw out something with replacement, 2 marbles in succession and noting the color each time. To draw with replacement means the first marble is put back before the second. For each of these listed below, write our outcomes that makes the event. If we assume each outcome is likely, find the probability of each event. The first one says at least one marble of each color. That means when you want to write, we need to, what our option is, when you pick 2 marbles from here, 1 and 2, it could be first white, second white, or it could be white, second black, or it could be black first, then the white, and all both black. The question is at least one marble of each color means event. This is like an event where the outcome that at least each color means both should be there. That means it could be white and black and white. So if I want to write probability of this A, then it will be there are total number here are 4 here. So 4 and these are 2. So 2 out of 4, which is half of 50%. And next one says no white. No white basically both black. So the probability of, so this is no white is probability of B. That means it is so it means this B is no white means it can be black white black. It has to be both black black. So there's only one outcome. So it will be number of outcomes for B divided by n of s, the formula which is 1 out of 4, 2. Problem number 3, again there are 6 here. This box contains 16 white and there are 16 black. And you want to pick 2 of them with replacement. It means you pick a marble first and then you put it back. You put it back. Okay. So then we have to write a sample space here. What are our sample space? In this case will be the first one. So they are picking 3, sorry. They are picking 3 marbles. I'm sorry. So there are 3. And when you pick, you note the color, put it back and pick another one. Note the color, pick third one like that. So it could be first one could be all white, or it could be white, black, or it could be white, black, white, or it could be white, black, black. See, or it could be first one black and then white, white, or first one black and white, black, or first one black, second black and then white, or all black. So these are the sample space that you have, and the number of outcomes that you have is altogether 8. At least one marble of each color basically means you have to look up for which other one has got. There has to be black and white also. That so both should be there. White and black has to be there. And I can't take this two. I can't take this two. But the rest of them, there are 6 of them. See, so there are 1, 2, 3, 4, 5, and 6. So this becomes this probability at least one of each color. So I'll call this as event A. We can call this as event A. At least one marble of each color, right? So when you write this, it is n of A. So how many are there? And you can see I already tick mark there. There are 6 of them. 6 out of 8, which is 3/4. The next is no white. It is all black. So there is only one black, one outcome. So we can write directly this as 1 out of 8. Next one is more black than white. So you're looking out for more black basically means, let's see, this species. There are 2 blacks and 1 white. So 2 black and 1 white, 2 black and white. And these are all 4. So there are 4 of them. So this probability is from 8, that's the sample space. We have 4, which describes this. So your answer becomes half. Question number 4 says a box contains 8 red, 8 yellow, and 8 green. So what does that mean is construct a sample space. So we need to write the sample space for the experiment and with replacement. It means if this is the box and they contain those 8 red, 8 green, and 8 yellow, so that means altogether 24. So when you pick how many 2 marbles are picked, right? So 2 marbles. When you pick 2 marble with replacement, and you pick one and you write down whatever that is, and then you put it back again, and you pick another one, and then so this will be your one outcome, which means the first one and the second one. So we can have starting with the red one, I can have the first one is the red and the second one also red. Or I can have the first one red and the next one is the green. Or the first one is the red and next one is the yellow. So these are starting with red, or you could start with green, and maybe the second one also is green, or green, the second one is red, green, and the second one. So these are options. Starting with yellow, it could be the second one also is yellow, or yellow, red, and yellow, green. So you can see there are altogether, this sample space has got 9 options. You can see 3, 3, and in between 3. So together 9. So the question is, what are the chances, probability? It is no yellow. That is mean probability of no yellow. It means the total number in the sample space n of s out of 9. This is that n of s is, you have some number of outcomes is 9, but from there, the one that has got no yellow, so which one has no yellow? You can see there's no yellow here. This one also does not have a yellow. This one does not have a yellow. This one does not have a yellow. And you can see there are altogether, okay, there are 4 of them, but this this one has yellow, this one has yellow, this one also. So these 4 have yellow. So these are the one. So that means uh, number of, maybe I can call this event as A as, so the answer is there are 4 of them out of 9 and you're done. The second one is 2 marbles drawn have the same color. Now I can say B means the 2 marbles with marbles. Don't worry about the spelling, with same color. So I can describe this way. That means how many are having the same color? You can see from here, the one that has same color is red, red, green, green, yellow, yellow. So there are 3 of them. So your answer is 3 out of. So this will be 3. So probability that the outcome will have same color means out of 9 there are 3 of them, and you're done. This one says what is the probability? At least one marble of each color. Now we have red, yellow, and marble. I mean red, yellow, and green. Now since we are picking only 2 marbles, so if we are picking 2 marbles, so these are the 2, where the question of red can go be the first one, yellow can be the second, and then we can't have another third color. So there is no third color here. See, we are only can have maximum is 2. So this is, if I call this C as at least one, marble of each color. That means probability of having each color is, because there are no outcome favoring it. So out of 9, there's nothing, 0. So the answer is 0. Question number 5. Your sock drawer is a mess, and there are 12. So if this is a, let's see, if this is your drawer. Okay. Now this drawer has got uh, 12 sockets. So these are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there are red also. These are 6 red. See? So 3, 4, 5, and 6. So there are 6 red and there are 12 black. So mm, when you pick when you pick one of these, what are the chances that without looking you pick a red? So probability of chances. That means we can call an event A that so the picked up stock is, you can say, picked up, you pull out one of them, picked up stock is red, and you can see how many are there, and the number of favorable outcomes for to pick a stock is there are 6 red, so this is 6. And if S is a sample space, which is all the socks, Okay, all black, 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 and then red, 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 like this. There are 12 of them, so n of s is 12. So probability of pulling a red sock, the A stands for red. So that means the total probability is n of s divided. And the top one is number of outcomes. That means how many red socks are there. So we write this way, and there is 6 out of. Uh, so altogether, this piece is 12 plus. So how many total number of socks, pair of socks are there? 12 plus 6. That's 18. So this is 18 here. I'm sorry here. So the answer is 6 over 18. And if you divide by 6 up and down, you get 6 1 over 3. And you're done. So just keep it this way. Okay, so here a ball is drawn from randomly from a jar. So this is a jar. And this one has got 6 red, 2 white, and 5 yellow. That means how many together will be here? All together there are 6 plus 2 plus 5. 8 plus 5 is 13 total. So that means n of s is 30. When you pick a ball, that means you're going to pick from 13. So here is this yellow. Find the probability of the ball is a red. So we can write now shortcut. The ball is red. And first of all, total number of balls, there are 13. And there are how many red? 6. So 6 out of 13 you're done. The second one is ball is white. So probability that it is a white ball is there are 13 of them. And from there are 2 white. So it is 2 out of 13 and you're done. So some questions are so easy like this. So question number 7 is suppose you write each letter of the alphabet on a slip paper and put the slip into a hat. So let's see, this is a big hat. Okay. And in this hat, you write slips on a paper like this, and you write A and B like this, and then put them in the inside here. So all of them are there, all 26, right? So this has slips like this. All together there are 26 of them. And then what is the probability of drawing one slip of paper from the hat at random and getting a assume y is a consonant for this exercise. So that means you're picking a consonant. These are 26, right? The question is, what is the probability that when you pick a slip here, when you pull out one slip, that you end up getting a consonant, right? So first of all, which are the consonant? So the non-vowel alphabets. So the vowel alphabets are A, E, I, O, U. So there are 5 of them, right? So from 26, you take away 5, you get 21 consonants. So consonants. So the probability of getting a consonant is now altogether there are 26 letters because this each of this slip has a letter A, B, C, D until Z. So that means there are 26 of them. So that 26 is the denominator. And the top one is number of favoring the consonants. So there are total number of consonants are 21. So that goes 21. We are done. But if the question is what is the probability of when you pull out a slip, it's going to you end up getting a vowel. So vowel is there are so first step is the ratio. So the total number of sample space means the hat contains 26. And from there, you're picking any one of these vowel letters, right? So there are 5 of them and you're done. Question number 8 is a group of people were asked if they had run a red light in the last year. 150 responded yes. Okay, I'll just write here 150 said yes, and 185 responded no. So that means we want to know how many were questions. So if we add this 5, this will be 335. These are total number of outcomes. These are total number of outcomes or the sample space. So when you talk about probability, find the probability that if a person is chosen at random, they have run a red light. So that means if I can say A is uh, person ran a red light, ran a red light. So we want to know what is the probability of this event A. It is the number of outcome favoring the event and total number of outcomes, that is the sample space. And you can see those who said red yes, so there's a 150. So you put 150 here, and the total comes at the bottom 335. If you want, you can reduce this by dividing by 5. But if you get confused, you can directly use the calculator. So this is going to be 30 over 67, or you directly use the calculator and you can get 0.4478. Sometimes they give you an option here, round to two place decimal. So then you want only this two digit, 10th place and 100th place. You can write 0. Because it's a 7, we can round it to increase this 4 by 1. That it becomes 0.45. Question number 5. In a survey, 200 people indicated they prefer cats. That means there are some who like cats, and they are altogether 205. 160 prefer dogs, so the dogs are 160, and 40 of them none. So they don't like no pets at all. So there are 40. And if you add this, you get 501, 405. So this is the end of total number of possible outcomes. So if you want to select from 405 any one of them, if a person is selected, suppose one person is selected, and ask him whether he prefers a cat, so the probability of the person like cats, I think I put it like cats. It means it is total is 405. So that means total number of uh, possible outcomes. And the one on top is the how many of them have cats, and they are all together 205. So if you put this on the calculator, just put this on the calculator, you get 0.56, which is almost like 50. If you move the decimal to the two places to the right, you get this divided by 100, which is 50.6%. I hope that makes sense. So compute the probability of tossing a die. So this is a die, and when you roll a die, so you want to know what number shows up, and we already know that this is 1, 2, 3, 4, 5, 6, 4, 5, 6. So from this, that means when you talk about probability, so we want to know probability that getting a number 5. So getting number 5, that means you have when you roll a die, you you have only one 5. You can see there's a 5 there, so there's only one. So it is 1 total number outcome favoring this. So 1 out of 6, and you're done. But if the question is asked getting a 7, so there is no 7. You don't see a 7 here. So the 0 out of 6 is 0. And compute a probability that getting an even number, and the even number there are three options. So this probability of getting an even number is 3 out of 6, and you're done, which is half. So compute a probability of tossing. Same question, but getting a number less than 2. Now, when you say less than 2 is, sorry, less than 3, he said, right? So those numbers which are less, this means these are the numbers. So 1 is less than 3, 2 also is less than 3. So there are two options here. So out of six, the probability of getting a number less than six is the ratio. So total number of possible outcomes is six, and from this there are two here. So two out of six, which is 1/3. Now this question says a deck of cards has 52 cards. So I think we did a lot of problems. These are 52 cards, and you pick a one card. What is the probability of getting a king? So that means you're picking one. There are 52 cards. From 52 cards, how many kings are there? And you know there are four cards. There are four kings. So this becomes dividing by four. You get four divides. Four divides 52, 13 times, and that's your answer. So this is also using combination. If you want to write from 52, you have C1, that means you're picking one. And the one that are favoring king is there are four kings, and from four king you can select one. This also is the same thing. 4 out of 52. That's because NC1 is always N. So in the previous problem 14, what is the probability? It was diamond. Now, how many diamonds are there? See? So we know there are altogether 13 of these. So from 52 cards, there are 13, which becomes, if you divide by 13, get 1/4, which is 0.25, which is also 25%. But if you keep this, that's fine. And I hope it makes sense. Or you could also write 52 cards and you're picking one card, and there are 13 diamonds, and from 13 diamonds, you pick one, right? So that also is correct. 16 is a group consisted of nine. Let's see, this is a group, and there are 9 men. Okay, these are 9 men, and there are 10 women. 10 women, and you want to pick four of this. See, you want to pick four, and altogether you can see 10 plus 9 is 19. So there are total persons are 19, and you want to pick four of them. So if I want to pick four at random, what is the probability that all of them are women? The first one is woman, the second one woman. So all four are women. It's like a group where all woman. So there's no. This doesn't mean that it is that the order important. Here order is not important. It is just a group of four people. Important. So you just want, that means all four are women. That means there are two parts here. But if you want to know probability all women, that means we need to know what is the probability of the sample space, or what are the total number of possible outcomes, and what are the numbers that are favoring that 10 women. So that will be like, maybe I'll put an event E is all four women. Now, two steps here. The first step is always the denominator. I always like to do this. So the number of total number of outcomes. How many different ways can you have these groups of four women? It could be men also. So we can have so many different groups of four. Maybe you're picking from 19. There are 19 out here. This whole 19 are there. So from 19, you are picking four. Now you can do this, put in the calculator and get the answer. Basically, what this means is 19 factorial, then the 4 factorial times, and you subtract 19 and 4, which is going to be which is going to be which is going to be this one. I'm gonna write 15 factorial, so this piece, and then the top one I can go all the way down, decreasing. 15 factorial, see? so that we can cross this out. But there is still this 4 factorial means 4 times 3 times 2. Okay. And you put this on the calculator, you get 3876. So this piece will go at the bottom. So this will be your 3876. Now we need to also know which one are favoring those 4 women, right? So there are, how many women are there? In this case is this group has uh, 10 women. So this piece that NE is from 10, you are selecting 4. So 4 women will be from 10. So you work this out again, the same thing, 10 factorial, using the formula of combination, and then subtract the 2, like this, which is, now this is going to be 4 factorial, 6 factorial. So I'm going to reduce this until 6 factorial. This 4 factorial will be 4 times 3 times 2, and this is 6 factorial, which will get crossed out. So this and this goes away, and you put this divide by this on the calculator. I think you get 210, and then you put and you work this out, and you end up getting 0.5, 0.0542. You're done. But the thing is that if you get confused with this, as long as you write this answer, see, you could also write this as 10. First of all, there are 19, and from 19 you choose 4 people, but the numerator is because there are 10 women. So this is the one that is favoring the woman. So from 10, you pick 4. So if you write this and put on the figure out of top piece, you get 200, and put this on the calculator, you get this. And then when you divide, you get this. So you can do directly like this. So I'm just showing you how it works. So this is one way to do, showing the work, or you can write like this to get the whole thing. Let's do another. Okay, question number 7 says, 17. So this is 17. This is 17. You own 16 cities. So there are 16 cities, like I say, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now this 16 cities has to be put in the order. So randomly arrange them in a rack. Now you want to arrange them in a rack, like this. See, this is your rack. Let's see, there are 5 spots here. So the order matters. So this is an example of permutation. Permutation, because which city goes first is now from here. See, there are 16. So the first piece could be any of this, like the 16 spots, right? So basically, you can use fundamental counting principle also and say, hey, the first one is any of the 16, or then once that is filled up, then the second one will be 15, and you know what I'm doing is just multiply like this, and you get the. So this will be total number of possible ways, uh, all different ways to do this. Total number of possible outcomes. So which is also written as, because we want to know what is the probability that the rack ends up in an alphabetical order. Now, alphabetical order means, now if there are like 16, maybe there are 16 alphabets, but then we want A, B, C, D, E, whatever that is. But the actual one is 26. But so what is the chance that they are in alphabetical? There will be only one. So the probability of an event that you put them in the alphabetical order means the top numerator will be always 1. So there will be only one way that is possible to have alphabetical order. This. So, but then what are the denominators? So this is the only the number of outcome favorable to the event. So the event is that they are in the alphabetical order. So there's only one, but the down one is number of possibility is, of course, this is directly, you can write 16 by fundamental principle of counting, or you say, okay, there are 16 of them, and it is P and into into 5 spots. See? So if you put on the calculator, you can directly get 5, 3, 5, 2, 4, 1, 6, 0. If you use the calculator, you get, you can put on the calculator fine, but I'll just leave it like this. Okay. So I hope this makes sense to you why it is permutation, or if you want to see this piece, it is by formula. It is 16 factorial because NPR is n factorial. Divide by, subtract the 2 and you get it. Okay. So that's the one. I mean 16 factorial divided by uh, 16 minus 5. And 16 minus 5 factorial, you end up getting uh, so 16, which you can go all because the bottom one becomes 1, 11 factorial. Okay. So it will 16, 15, 14, 13, 12, and 11. So that 11 factorial will cross our edge, and this is what is the same thing. But as I said, you could directly do like this. So there's only one option to have alphabetical order, but then your total number of possible outcomes. Picking 5, it is such a big number here. So I hope that makes sense. Question number 18 says a jury pool consists of 24 people. That means this are 24, but in this there are 14 men and 13 women. Okay. Compute the probability that randomly selected a jury of 12. It means if you do, I mean, you're picking 4, 5, 6, 7, 8, 9, 10, 11, 12. So you pick 12. What are the chances? What are the probability that all women, see, sorry, all 12 male, all 12, so all 12 male. Now, first is, remember, when we talk about probability, it is always two parts. One is it is a ratio, and the bottom one is n of s, and the top one is n of e. So we need to know step one is what is the total number of possible outcomes with n of s. It means you how many different ways can you pick 12? So not only male, it could be woman also. So 12 women are to be selected. This is the thing, see, and I want to select 12 members. You see, there are 12 of these pieces. So we need to place 12 here. The order doesn't, it's just a group of 12. And you're picking it from 27. So this becomes from 27, you're picking randomly 12 of them. So if you use the calculator, this answer is 17,383,860. See, so that part will be at the bottom here. This will be 17,383,860. Now, what is the meaning of this piece? The second piece is is when you pick all are women. So that part I'm gonna do it right here. So, so when you pick this 12, not here, I think this one, they are all just 12 are 12. That means there are 14 men, right? So NE means all men. What does this means? All men. So there are how many men? 14 men. And from 14 men, you're picking 12. Now this, when you put on the calculator, you get 91. So this 91 will go here, and then when you do the division of this, you get 0.523. That's it. So this is how you have to do. So two steps. Okay, first it's all male, so it's a ratio. First find this. This is step number one, and this is step number two because you want to find the numerator. So the one that number of outcomes that are favoring the event E, which is all men. Okay, they could have asked maybe out of 12, maybe 8 men and maybe 5 women. Then the whole question changes. See? If they had to ask, I'm just changing this question. If they had to ask us 8 men and 5 women, so it will be, first of all, there are 27, and you're picking these all together 12, right? So C 12. And then you'll have to do two parts. The first part is 8 men. There are 14 men, and from 14, you're picking so 8 men. And once that is done, the other 5 members are women, so that they will be out of 13 because there is 13 women, and then you're picking 5 of them. See, so this is how the problem changes depending on the question is. So as long as this number has to be together, 5 plus 8, this 8 and 5 becomes 12. So that's how you're selecting a jury of 12 from here. So jury of 12 members. I hope I'm making sense. Question number 19 says in a lottery game, a player picks six numbers from 1 to 8. So if this is 1, 2, 3, and so on, and then 47, and the next one is 48. There are 48 here. And if 5 of 6 numbers match the drawn, that means when the lottery is being drawn and you had picked 5 numbers, okay, of these 5 numbers, you get 5 correct. So green. Now let me use the blue as that means you got 1, 2, the first number, second number, third, and the fourth and the fifth you got correct. So these you got correct. All this one, right? But the red one of them you did not get correct. So this is wrong. This you did not get. A sixth number is a non-winning number. I will say non-winning number. But the one that you got 5 of them is a winning number, right? So so these are winning 5 of them. So then when you talk about probability of 5 matching the numbers, so you win the second prize because you have 5 numbers. So the probability of second prize is basically means you get 5 winning number, winning number. But it means it is probability that you got 5 winning numbers and one non-winning number. One non-winning number. So here there are two parts. First of all, probability NS, all possible 6. How many total number of possible 6 numbers can be chosen? And N is the event means that means you're matching the 5 of them. So this means the total is, since there are 48 numbers, so from 48 you pick any 6 numbers. So that will give you the total number of possible outcomes. But the top part, you got 5 winning. That means actual win will be there are 6 winning numbers, right? So from 6, he got he got 5 winning numbers, and then the other number is a non-win. That means from 48, you have to take away the non the if you want to know how many non-winning number, so this will be 42. So there are 42 non-winning number. So this is 42 and C, and he got one non-winning. So this is the most important equation. And if we do this little calculation here, so sorry, here I made a mistake. This will be 6. We are picking 6, right? So let me write it here. So this is the bottom part is 46 is 12 million, And this number, when you put on the calculator, of course, it is 6 times 42. So it will be, you will get 252. And when you put on the calculator, you get 0.0000 and 253. Okay. So I hope this makes sense to understand how it works. So important thing is, important part is this piece. How did you get this? So most of the students, they do get the first one correct. So this piece, because they say, oh, six are winning numbers and you got six. But then also you have to multiply it by the non-winning, one of the number which was wrong. So it was out of 42. So you have to take care of that also. It's the same question, but this time they're asking you got four out of six you got correct. That means if this is the numbers, say like this, he gets one. So this is correct. This is correct. This is correct. So these are the four. So these are correct. Means he get four numbers correct. So the probability of uh, four numbers are matching. So probability of four matching numbers, you win the third prize. I think this is what is the probability of winning this prize? So which is the third prize. So the total number is the same, 48 C 60. You're picking six numbers, but then now the option changes. So winning numbers are one, two. You got one, two, three, and four. I hope I'm making sense, right? Yeah. So that means from six numbers, because altogether six numbers are altogether there are six correct pieces, right? From this he gets four. That means three, four, four correct. And he gets two wrong. That means there are 42 wrong ones, which I showed last time. And from here he gets two of them. So these are the two wrong ones. These are the four right ones. So four match, but two don't match. So when you put on this calculator, this is the same 12,271,512. But this number, when you put, you end up getting 12,915. And when you do this, you get 10524. I hope this makes sense. Question number 21. Compute probability that a five-card poker hand is dealt to you. Compute the probability that when you play five-card poker hand, that that contains all the hearts. That means probability. I will say all five all five cards are are hearts. So you got all this. These are 13. There are 13 hearts from the deck of cards, which has 52 cards. So from 52 cards, right? So you want to know all five. That means how many different ways can you? So the bottom piece, the step number one is you need to know that so the total number of five cards picking from 52. The total cards are 52, and you're picking five cards. And so this is all possible outcomes. So, but then the top one is you have to see there are 13 hearts. So from 13 hearts, you want all five hearts. So that's how you write this. So this will become, the bottom will be 2,598,960, and the top one will give you 1,287. If you do little calculation, you get 0.000 and 495. So, and the same question, if it is they're asking all four aces, that contains four aces. So when such thing is asked, probability, the bottom piece stays the same. That means you are from 52 cards, you are picking five cards, but now this part says four aces. That means in a deck of 52 cards, there are four aces only, right? So that means there will be 4C4. So from the five cards, four are aces. Okay, I'm sorry. I think so. Since they're asking for four aces, uh, that means four ace card and the other one is non-ace card. So this deck of cards contains 52, and in this deck of card there are four aces, right? These are these are four ace card, ace card, ace card, ace card, ace card. That means you have from four we'll pick four out of three. 434 basically means you are picking the first four from this, and then after that, the other card, the fifth card has to be chosen from non-aces. So if there are 52 cards, from 52 cards, if you subtract four aces, so what's remaining is 48 non-aces. Okay, so that's why we have to write this number has to be 48. This. If you calculate this, first one will give you. So this actually is already one, but what if it is different? So you put this on the calculator, you get 40, and the bottom piece 52C5, you get 2, so you get this. So the idea is, can you set it up? This is the important piece. Once you do this, the rest follows. So question is, the bottom one is always the total number of possible outcomes. The top part is the number of outcomes that are favoring the description, that is four aces. But because there were already four aces, so I'm just writing this as it is. But if the same question is asked, in the next one, all red. Oh, this one is different. Being there will be six cards. It means you are picking from 52 cool cards, you are picking six cards, and that are all red ones. That means the red cards are 13, so it is from 13 you are picking all six red. So this will change to 20 million here. And this is 230 on the calculator. And then when you take the ratio, you get 0.0113, which is like 1.13%. So I hope I'm making sense to you. Question number 24. The following two-way contingency table gives breakdown of the population in a particular locality according to the age and tobacco use. You can say age under 30, smokers are given. So tobacco use are smokers and non-smokers. So they already give us the numbers what out of. So basically it is zero. If I write 0.5, what this means is 0.05 out of 1. This is like a relative to 1. That means this basically means if I multiply 100 and up, down, this becomes 5 out of 100. The decimal moves two places, just like 5%. See? So 5% of, so when you write this 5% are smoker and under 30. That's what this basically means. And the question is asked, oh, if you select a person, that means out of 100, so just think of out of 100, the person is a smoker. So that means we have to see all the smokers under 30 and also. So what does that basically means? So all smokers are this way, under 30 and over 30. So all you do here is probability of smoker is 0.05 plus 0.20, you get 0.25. That's it. This means under 30. Person is under 30. So this time we'll have to do this way. This is under 30, all this total. You can also do extend this like this and get the answer also. Okay, so this under 30 is 0.05 plus 0.20 0.20, you get the same answer. A person is a smoker and who is also under 30. So that means you can see this number is a smoker and this number is also under 30. So the answer is 0.20.